Dear students, Thiel has proposed one non-parametric method for estimating the parameters of the simple linear regression model. Usually in the presence of outliers, the standard classical method, which is the least square method, may not be providing the correct estimates for the slope of the line of the regression model. Then the Thiel method may be used because it is a robust method against the outliers. So students, usually whenever we talk about real life data sets, we may come across with most of the influential points that are present in the data. So the least square method may suppress those estimators, or there might be overestimation as far as the particular parameters of the regression model are concerned. So we can make use of the Thiel's procedure that was proposed by Thiel. It is a non-parametric procedure that will consider if, for example, there are certain kind of departures from normality, which is one of the basic assumptions under the simple linear regression model, then Thiel method may not actually assume that the population, the parent population must be normal. So the it may cover that problem of the outliers or some other assumptions that are not met with the simple linear regression model. The Thiel method, students actually make use of the Kendall-Stava statistic to estimate the unknown value of the parameters of the simple linear regression model. So under H0, we usually assume that beta is equal to beta naught. So students, we would be talking about certain assumptions that are required to apply the Thiel's method to estimate the parameters of the regression model. So under Thiel's method, we are assuming to test that H0 beta equal to beta naught, and Thiel method will make use of the Kendall-Stava statistics for testing this particular kind of H0. The appropriate model, that is the simple linear regression model, yi equal to alpha plus beta xi plus epsilon I, where epsilon is the errors, and we assume that EIs follows normally independently distributed with zero mean and constant variance. So students, if some of the assumptions of the errors even they are not met with the simple linear regression model data, the sample data that we draw from certain populations, then we might be in trouble because we cannot make use of the least square method to follow, and we cannot actually afford to assume the assumptions that are not met with the data. So we can make use of the Thiel's method. Suppose students, अगर आपका यहाँ पे जो एरर का वेरिएंसेस है, अगर ये कांस्टेंट नहीं आते जो कि कांस्टेंट होने चाहिए इन ऑर्डर टू बी वेरिएंस टू बी होमोसेडास्टिक इन नेचर, सो अगर ये आपके जो वेरिएंसेस हैं ये कांस्टेंट नहीं होते, वेरिएबल बन जाते हैं, दैट इज बीइंग कॉल्ड एज हेट्रोसेडास्टी. सो हेट्रोसेडास्टिसिटी अगर प्रेजेंट है आपके एरर्स में, सो वी कैन नॉट इवन मेक यूज ऑफ द least square method to estimate the slope of the line. It would be better to estimate the parameters using the Thiel method in that situation. Similarly, we assume that the data consists of n pair of observations. We'll be considering them in pairs on the continuous variable x and y, where each pair of observation is a measurement on the same unit of association. So that is the requirement of the simple linear regression model. Now, as far as assumptions are concerned under the Thiel method, the first assumption is that the appropriate model yi equal to alpha plus beta xi plus epsilon I is to be tested where the xi's are known constants, they are fixed actually, and alpha and beta are unknown parameters that are to be estimated. Students, actually these are the population parameters. यानी आपका जो population regression model है yi equal to alpha plus beta xi plus epsilon I, ये उसके parameters हैं. Unless otherwise you estimate these parameters, you cannot predict yi on the basis of xi. Then the next assumption is that for each value of xi, there is a subpopulation for y values. Moving on to the next assumption, yi is an observed value of the continuous random variable. So students, yi are strictly measured onto the interval or ratio scale of measurement. So they are continuous random variable y at the value of xi. Then the next assumption is the xi's are all distinct. That means we assume that there are no ties, and we take those observations, we actually arrange them from largest to the smallest. So x1 is actually assumed to be less than x2, which is assumed to be less than x3, and so on less than xn. So students, हमने उनको order में arrange कर दिया है, जहाँ x1 जो है वो सबसे the smallest observation है आपके data की x की, और उसके बाद we assume कि x2 is considered to be greater than x1, and so on we arrange them. And finally, as far as the errors are concerned, we consider that errors are mutually independent. That means E1 is independent of E2, E2 is independent of E3, and it is independent of En. And we usually assume that these errors, they come from the same continuous population. So students, if these assumptions are met with your population, then we can make use of the Thiel's method to estimate the slope of the line.